Welcome back. Here we are, the first kind of real NSX specific content that's not the introduction. This is the VMware Virtual Cloud Network and VMware NSX. Now, what we're going to get into here is a couple of different things, right? Two primary topics that we're going to look at in this video. One is the Virtual Cloud Network framework from VMware. And this is just kind of a high-level view of how NSX fits in the context of the software-defined data center is really what we're looking at, or the hybrid cloud, or any other set of infrastructure. And then we're going to talk about the kind of different roles and functions that NSX provides at some level, right? Internal functions, before we get into some of these videos later on about the technical functions. So that's what we're here into is the Virtual Cloud Network. And then we're going to talk about NSX. And so what is the Virtual Cloud Network? Well, the Virtual Cloud Network is a software layer that gives us networking and security everywhere. We'll talk about that. We'll talk about why that makes NSX valuable, what the benefits are, what the use cases of NSX are, kind of how NSX fits into the broader networking and security portfolio in VMware. We're going to talk about some things then that were changed or deprecated in NSX 4. Some of these are kind of a big shift from where we were, and that's kind of where we're talking about this. So if you've seen or worked with NSX in the past, these are going to be of some interest, I think. And then we're going to talk about the different functional planes, the manager, controller, and policy roles that exist in NSX Manager. So there's a goodly amount of stuff coming up here. So the Virtual Cloud Network framework is this idea that we have that, we used to enumerate this or talk about this as any, right? Any network, any cloud, any workload. And we've kind of refined that into the Virtual Cloud Network, where we're really talking about providing a software layer between the workloads and the network so that we can provide kind of seamless policy-based networking and security, really, for all of these different workloads. We can kind of rethink how we're approaching the network. And we're providing this in the context of a larger networking and security portfolio, right? So we've got a whole bunch of tools, a whole bunch of different products and capabilities that we're looking at in what we would consider the data plane of the infrastructure that are providing networking, right? Switching and routing capabilities, that are providing security capabilities, that are providing load balancing capabilities or SD-WAN capabilities or things like that. And then we've got other tools to kind of help manage that whole thing, right? When you think about it, networking and security, that's a pretty broad set of topics together, much less individually, right? Networking is a really broad set of things. Security is at least equally a broad set of kind of tools and disciplines that we might be looking at. And so we're kind of putting these all into one really, really large portfolio. Now, if we sit down and look through what's on the slide here, we can kind of get into a little feel of the different products that are involved, like VMware NSX, like VMware SD-WAN, like the NSX Advanced Load Balancer, and other kinds of things like that. If you need some more time, feel free to pause the video and kind of look through what's on the slide and kind of dig through that. But when it comes down to it, consistent networking and security across environments is not something that we can provide out of a single product, right? We've got a whole number of tools here that are really necessary to make this all happen. Now, NSX 4, right? This is a big change going from prior versions to now. And if you look back at older versions of our NSX stuff, whether it's documentation or things like that, you'll notice that we used to discuss NSX for vSphere. We used to discuss NSXT or NSXT Data Center. And in January of 2022, NSX for vSphere went end of support. So we shouldn't be using that anymore. That left us with NSXT Data Center as the product. Well, we've decided over time that it's time to simplify that. NSX4 gave us a great opportunity to kind of revisit branding for NSX just a little bit. And so we've refined the brand and the product name to just VMware NSX. And that's a subtle difference you'll see, but it's a difference you're definitely going to see, especially if you look at older documentation. So that's a big change. Now, why do we use NSX? Well, we use NSX for security. We use NSX for networking across multiple clouds. We use it for driving an automated data center. We use it for cloud native applications. Containers are very much a first-class citizen in the context of NSX. Now, I'm not going to read through all of these different features in platform networking and security services here on this slide. You can again, anytime throughout this series, feel free to pause the video. That's the great thing about video, is you can pause it and read more carefully what's on the screen, and then unpause it and listen to me some more. That's fine. But go ahead and take a look at some of these different features and capabilities that NSX provides. We'll have another one of these slides here coming up in just a second. So I'll give you just a second to pause here and to read. And then we can come on to the next features where we look at the automation features, the operations features, the troubleshooting features of NSX. And again, just like the last one, tons of bullet points here. Pause the video. We'll start back up here in just a second. All right, that should have been enough time, however much time you had the video paused. So let's talk about some deprecated features in NSX. Right, in NSX 4. Now, we talk about NSX 4.0.0.1, and there's some interesting versioning stuff going on with NSX right now. The version of NSX 4.0 that you would download and deploy on-prem or on-premise, on your premises, in your data center would be NSX 4.0.0.1. So what have we lost? What have we deprecated in this version? Well, we've deprecated the NSX virtual distributed switch, or the NVDS host switch on vSphere platforms, on ESXi, right? Meaning that we're going to have to use the vSphere distributed switch for the host switch, for the host level virtual switching component. That shouldn't be a huge deal, but it is something absolutely to think about, especially if you're looking at upgrading from a previous version. We have deprecated support for Linux KVM as a supported hypervisor. We still support bare metal Linux servers, but not KVM as a platform. And then the advanced load balancer, the NSX advanced load balancer in NSXT Data Center version 3.2 was introduced as the load balancing engine going forward with NSX. And in concert with that, we started to build some UI and NSXT API elements to manage the NSX Advanced Load Balancer. And the decision has since been made to go ahead and take that development effort and focus more on improving the Advanced Load Balancer itself and leaving that functionality, the configuration and control functionality of the Advanced Load Balancer, to the Advanced Load Balancer UIs and APIs. So we're starting to take those NSX advanced, or the NSXT APIs and UIs out that control the advanced load balancer. We'll actually see some of that later on in the context of this class, because load balancing is still a very important thing for us to think about. So those were the things that we kind of deprecated in NSX 4.0.0.1. Now, if we look at the architecture, this has not changed, right? Since we're kind of thinking about days gone by and earlier versions, the architecture of NSX really hasn't changed. We've got three functional planes that we want to think about. We have a management plane, a control plane, and a data plane. The data plane is provided by the hypervisors and the bare metal servers and the NSX edge transport nodes and cloud virtual machines and things like that. The data plane is where we process the packets and forward the packets around. We do the networking. We do the work, really, that NSX does down in the data plane. The management plane, that's what you and I are going to interact with as we're going through and preparing to do all of our NSX stuff. The control plane is an intermediary functional plane that takes inputs from the management plane and ensures that the data plane gets programmed accordingly. It also takes inputs from the data plane so that we can understand things like the current runtime state. We can have visibility into NSX, and we can have visibility into our networks and so on and so forth. So we need all three of those planes for NSX to function the way maybe we would otherwise expect. Now, the management and control planes are co-located in the NSX management cluster, meaning that they're simply roles that exist in this set of virtual appliances that we'll deploy. The management plane provides us our API and our UI, and the control plane does all of its stuff, right? Runtime state and making sure that the data plane is programmed how it needs to be and so on. Now, this management cluster, right? This management cluster is a set of virtual machines. It's a set of three virtual machines, three NSX manager virtual appliances that we're going to deploy. And when we work with when we log into NSX as a user, I log into the web UI or I log into the API or something. I create a session there. I'm going to use a single manager out of those three. So if I log in and I get connected to manager A, then I'm going to use the policy manager and control plane roles in manager A. Now, if you're logged into manager B, well, you're going to see everything that I'm doing, and I'm going to see everything you're doing because we share a distributed database, right? There's a database on each of the manager nodes, and that's going to share information back and forth in real time. Now, how do we kind of access these? Because I don't want to have to worry about I'm logged into manager A and you're logged into manager B. I don't want to have to give someone a DNS name or an IP address for a given manager. I probably want a single point of access for those three manager nodes. And so we're going to do that one of two ways, depending on the subtlety and the nuance of our particular environment. More than likely, we're going to use the cluster virtual IP function that's built into NSX. That's the easy way to go. Now, it's not always going to be the right way, but that's the easy way to go. And so, if all three of my NSX managers are in the same subnet, they're on the same VLAN, I can set this up, and this is a function baked into NSX. I don't need any extra equipment or software to do this. And what this is going to do is this is going to set up a virtual IP address on one of my managers, and that one manager will respond to all requests for that virtual IP. And when I log into my NSX VIP, it'll go to manager A. And when you log into the same NSX VIP, you'll also be logged into manager A. And then manager A ends up doing all of the management work for the infrastructure. Now, that doesn't mean that managers B and C are completely idle, right? They're receiving updates all the time. And if manager A fails, then that virtual IP address will automatically be transitioned over to one of the surviving manager nodes, giving us an automated HA, which is great. However, there's no load distribution here, right? All of my traffic is going to go to whichever manager has that virtual IP address. Now, maybe I need load distribution across my three different managers. Maybe I'm overloading a single manager with the number of API calls I'm sending, for example, because I'm in a far more dynamic infrastructure. Or maybe my physical infrastructure is laid out in such a way that the location of my three different manager virtual machines ends up being on three different subnets, maybe in a layer 3 spine leaf fabric where manager A is in rack A and manager B is in rack B and manager C is in turn in rack C, where each of those racks has their own unique management subnet. Well, if that's the case, the virtual IP is not going to work, right? The built-in virtual IP. In those cases where I need distribution or I have different subnets or things like that, then I'm going to need some kind of a load balancer to sit in front of my NSX manager cluster. Right? It's not a big deal. We can set it up. It doesn't have to be anything complicated. It can be a simple virtual machine, perhaps running maybe an open source load balancer like HA Proxy, or maybe NGINX doing some load balancing, or whatever it might be. It could be, it could be a virtual service you've got configured from an existing NSX Advanced Load Balancer deployment, or your F5 or NetScaler, whatever you might happen to have. Right? The thing here is the load balancer itself is not important. I just need a load balancer out in front of my NSX manager, my manager cluster more specifically. So, which way is the right way? Well, that has the classic answer of it depends. We probably want to lean towards simplicity in the cluster VIP, but there are going to be cases where we need to move towards a load balancer as the location for that virtual IP address rather than built into NSX. So it's just a couple of different choices, right? A couple of different choices we can make. Now, back inside the manager, if I'm looking at a manager, I see three different roles, right? I see a policy role and a manager role. Those both live within my management plane. And then I have a controller role. And these three roles are going to exist. They're provided by different services in the NSX manager itself. Policy provides what we call a desired state configuration, where I'm going in and configuring what it is that I want. I'm not just going to configure a network. I want to configure a network with a subnet and maybe a gateway. Maybe I have some DHCP options, right? I've got a lot of things that go with that network configuration that are going to make that network usable. And so that's what the policy role is all about. It's that bigger picture, that end state that I'm looking for. Now, the manager role, which also lives in the management plane with the policy role. The manager role is responsible for taking that desired state from policy and making sure that we have all the tools to make that happen. Manager is what we would call an imperative state configuration tool, where we're taking all those individual building blocks. So, I want to create that network. Can I create that individual layer 2 domain? I want to attach that network to a router. Can I build that router port? How do I configure that router port? All of those individual things that we might want to look for. So the manager role takes the input from the policy role and breaks it down into all of the individual configuration components that we may be concerned about. It's then going to take those configuration components and hand them to the central control plane, and the central control plane is going to be responsible for making that all happen. We'll see that in a second. Now, all of these things, right, the manager role and the policy role, both persist data, meaning they write their data when things are changed. They write that to this core foo database. That's that distributed database that exists on all of my different manager nodes. And so that's how everything knows. All the different managers know about all of those different changes that are being made, is because they're all written to this database, and this database is replicated and distributed accordingly. Now, once manager is done with all of its stuff, it's going to push that desired configuration, that set of configuration bits, down to the central control plane. The central control plane is here to ensure that the data plane gets programmed accordingly, right? So, what transport nodes or ESXi hosts or edge nodes or things like that, what nodes need this particular configuration? How does this configuration need to look? And so on and so forth. The control plane also takes inputs from the data plane and helps to figure out, what's the current runtime state of the infrastructure. What are we doing in the infrastructure? What do things look like? What are my visibility points, and so on and so forth? And so the control plane, right? The control plane is critical between the management plane and the data plane, right? The control plane is what makes it all happen. But it's not all centralized, right? The control plane is actually broken up into two pieces, one of which we've been looking at, the central control plane, the controller role on my NSX manager nodes. The other piece of the control plane is called the local control plane. And the local control plane is embedded on each transport node, whether that transport node is an ESXi host or an edge transport node or a bare metal server, whatever it might be. Each host, each node in the NSX domain has its own local control plane component. And the local control plane is what does all the localized work, all the work inside that transport node itself. So, the central control plane builds everything. It's kind of the central hive mind, if you will, the brain of the control plane. The local control plane deals with things locally. It'll deal with, the local control plane knows about the link status of the NICs, for example, because the NICs are right there on the same host. The central control plane doesn't know about the link status of any given network adapter, for example. So the local control plane needs to be there for all of the local components of NSX, right? All of the distributed components on the transport nodes themselves. Now, one control plane node, one central control plane node, is not responsible for everything. All right. Unlike the management, where, when I connect to an NSX manager, I'm using that manager for all of my management. The control plane is distributed across all three of my manager nodes. So if I log into Manager A and look at it and think about Manager A, Manager A's control plane is only responsible for some of the ESXi hosts, right? Manager B's control plane is responsible for other ESXi hosts, and Manager C's control plane is responsible for yet more ESXi hosts. So each ESXi host talks to one controller to receive its updates and to send data, configuration change, state change, things like that, to send data back to the central control plane. So the ESXi host will send back to the control plane. The central control plane will propagate that to whatever other hosts need that configuration change, but it may not come from the same controller node, right? May come from, here we've got two nodes that Manager A is responsible for, one that Manager B is responsible for. So we've got to let that update propagate through the system in order for that to actually, in order for the changes, to do their thing. Now, how do we figure out which manager node is responsible for which transport nodes or ESXi hosts? Well, that's a function called sharding, right? And so every ESXi host is kind of set up as what we call a workload or a shard. And those shards are sort of distributed across the available manager nodes. And so different transport nodes are programmed by different managers or different controllers. Well, what happens when a controller fails? Well, it's pretty straightforward. The shards that were on that node will simply be redistributed to surviving nodes in the manager cluster. That's all it is. There's nothing complex happening here at all. We're distributing things along. If something does happen to fail, we're just going to pick up the pieces that had failed and put them back on other transport nodes, or on other controller nodes rather. And that's not such a big deal because all of the information for all of the shards is in that distributed database. So if one node fails, well, we've got that information in the other distributed database instances as well. So we're not losing anything here. Now, the data plane is simply what we're using to process all the packets, right? We're distributing the work of networking. We're distributing the work of security across all of your different ESXi hosts, across your different bare metal servers, across your edge nodes, across your cloud workloads, right? And this is what's doing all my packet processing. So, we're going to worry about things like overlay tunnels and link failovers and, packet forwarding, whether it's switching or routing, either way. The data plane is responsible for packet statistics and feeding those statistics back to the control plane, which is going to feed those statistics back to the management plane so that you can see packet counters. The data plane is responsible for, like I said earlier, doing the actual networking and security work in NSX. Now, my transport nodes could either be hypervisors, right? ESXi hosts. They could be bare metal servers. Bare metal servers could be, a Linux or a Windows server that you haven't virtualized that you want to prepare for NSX and integrate into your NSX domain. It can be your NSX edge nodes in an edge cluster where you're providing resources for centralized routing and other centralized network services that maybe can't be distributed. So we've got a number of different things that could be data plane components here. Now, as we look at the communications of NSX and the communication channels, we're going to use TCP 1234 and TCP 1235 between the managers and the data plane nodes themselves, right? So the transport nodes and the managers. TCP 1234, that's what we're going to use for the management plane. And TCP 1235, that's for the control plane. Right, so we use, depending on which port we're using, will help us identify what type of traffic we're pushing back and forth, and we're going to see these things over and over and over again as we continue through this class. So that's a high-level view of NSX, and boy, is that a high-level view. We've got all kinds of stuff that's going to dig deeper and deeper and deeper into the management plane, the control plane, the data plane in particular, how all these pieces fit together. We talked about a couple of things that went away in NSX 4 that we want to think about moving into this new version of NSX if we have earlier versions. We've talked about how we fit into the larger networking and security portfolio a little bit as well. So take a couple of minutes and kind of think about this. We're going to come back in the next video and start getting into deploying NSX. The next video is all about deploying NSX Manager. And then we'll start getting into things like preparing the data plane, right? Preparing those transport nodes and getting all of these pieces that we just talked about, getting those all set up so that we can start using them. So come back in the next video. We'll see you there.